Welcome to this tutorial on distributed machine learning training with PyTorch using itwinai. So nowadays the current version is the itwinai 0.2.1, although we're currently working on a patch, so this may change soon. So let's see what we mean when we talk about a trainer. So a trainer, as you may remember from the video on the pipeline that I will link below, is a component that defines an interface to interact with other components in the pipeline. And the trainer is implemented as a Python class, which has a method called the execute method, like all the other components in the pipeline, which receives 3 arguments in order, which are the training dataset, the validation dataset, and the test dataset, and returns at the end of training. It propagates the same dataset, so training, validation, and test, plus the trained machine learning model. Then, the way in which these datasets are represented in practice is left to the user, is left to the developer. So the trainer is not constraining in any way the data format or the machine learning models that you should be using when using the trainer. So just to recap, let's see how the trainer block could be used inside a pipeline. So this is a toy example on how the trainer could be used in an itwinai pipeline. So as we can see, we get some data, we perform some data splitting, then the data splitter will return 3 datasets, which may undergo some pre-processing. And again, the preprocessor, as anticipated, will return these 3 datasets, which are passed to the trainer, which in turn will perform machine learning training on top of these datasets, returning also a trained machine learning model. So, but today we are actually curious to learn more about the TorchTrainer. So the TorchTrainer is a Python class which extends the trainer, providing functionalities for machine learning training for models based on the PyTorch, basically for PyTorch models. So what are the problems that the TorchTrainer is solving, and why a developer should use the TorchTrainer? So first of all, let's assume you already have your code, but you don't want to you don't want to understand how distributed machine learning should work. You don't care about that. You just want to take the code that runs on your laptop and without many changes, with as few changes as possible, you would like to take the same code that runs on your laptop and scale it to hundreds or thousands of GPUs with low effort. And this is the first functionality that the TorchTrainer is providing to the user. So all the boilerplate code to take a single model and distribute it over multiple GPUs in a data parallel fashion so far. The second problem that the developer may encounter is while developing a new machine learning model is using state-of-the-art logging frameworks such as MLflow, weights and biases, TensorBoard. So the developer doesn't have time, doesn't want to spend resources on learning logging frameworks, on comparing them. So again, itwinai TorchTrainer provides an easy way to access to these logging functionalities, and we will cover more on these in future videos. So stay tuned for that. Again, the TorchTrainer is streamlining how we compute metrics when we're training or validating our PyTorch models. So this trainer allows to reuse the so-called torch metrics Python package. So you don't even need to write, to reinvent the wheel. You can reuse existing popular metrics out of the box. Now, another problem that especially researchers encounter is developing in parallel multiple training algorithms for different machine learning models and then comparing them. So it is very hard to organize all of the training scripts and training logics and training configurations, different models. So it's very easy to get lost in this jungle of models, especially when you're trying to beat the state of the art. So again, the TorchTrainer, together with its functionalities, provides structured way to organize your code and to organize different training algorithms for different models. So you will implement different torch trainers. If needed, you can extend it. It's just a Python class. So you can extend the torch trainer and implement different algorithms. And then you will choose whether to use the torch trainer or not. Different trainers, you will decide whether to use them or not in your pipeline. But if you're not using them, you're still keeping them in a well organized way with the separate configuration. So this allows again to play around with different training algorithms. So and eventually, the TorchTrainer again is just a Python class. So if it doesn't provide enough functionalities for your use case, you can still extend it easily. And we will see today and in the next videos how the TorchTrainer can be extended to support more complicated use cases. So for today, let's see what happens inside the TorchTrainer. So what's happening when we call the execute method and we pass the train, validation, and test datasets. So in this pseudocode, you can see two different colors. So in green, I'm representing the boilerplate code, which is not interesting for the developer, in the sense that it's just setting up the distributed strategy, is distributing the torch data loaders, distributing the model, distributing the optimizer, the learning rate scheduler. So making sure that all of these components, all of these items are well prepared and ready to be used in a distributed environment. Also, the boilerplate code is setting up the loggers. So as I said, for the users, it will be easy to switch between loggers, almost as just setting a flag, like I want to use on the flow, or web devices, or both, or just a tensor board. So TorchTrainer, in other words, allows the user to focus only on what's important. So basically the train function. The trainer already provides an implementation for the train function, but this implementation can be overwritten by the user, providing, of course, custom training logic. So at the moment, the TorchTrainer iterates over the epochs. So for each epoch, it will call a train epoch, validation epoch, and test epoch method, which again can be overridden by the user, by the developer. And then, for instance, let's take the train epoch. Inside this method, we will iterate over the train data loader and call for each batch the train step, passing the train batch plus the batch ID. And again, this let's say structure provides a simplified way for the users to override only what is strictly necessary to their training workflow. So depending on different needs, the users will be able to override only what is really needed to be changed, reusing all the rest from the TorchTrainer and reducing the development time, of course, and the debugging and so on. So if you know PyTorch Lightning, the itwinai TorchTrainer seems very similar. So in the end, it's trying to solve a similar problem, and it's a similar concept. The main difference is that compared to the PyTorch Lightning Trainer, the itwinai TorchTrainer is simpler and is more lightweight, and is reducing the constraint on the user. So again, if you already have a training script and you don't want to change it, because this is the end goal of itwinai, so do not over-constrain the developer, but help the developer to improve what they already have with low engineering overhead. So if you already have a training function, most likely you can just copy-paste it inside the TorchTrainer, and with few changes that we will see in future videos, you will be able to reuse what you already have without having to comply with a predefined structure, such as in PyTorch Lightning. And so let's say it's more. And another advantage is that the TorchTrainer allows us to better comply with the requirements from the scientific use cases that we are supporting. So if you want to know more about itwinai and the TorchTrainer, well, you can know more. The best source of information is the itwinai documentation. So let's just jump the documentation and let's have a walkthrough. So here you can find all the information you need about itwinai. So installation, of course, integrated use cases tutorials. But today we're going to look at the Python API reference. So if we go into itwinai PyTorch modules and then trainer, we are looking for the documentation of the itwinai.torch.trainer.torchTrainer, which is the class of interest. So when implementing this trainer, our goal has been to make it as generic as possible in order to support as many training algorithms as possible. So as you can see, the constructor arguments are extremely generic, like the number of epochs, the machine learning model to train, the name of the distributed strategy to use, like DTP, so Torch, Data Parallel, Microsoft DeepSpeed, or VOD. So again, the user will just set a string, so keep the name of the strategy, and then the TorchTrainer will make sure to distribute the training according to that strategy. Some flags, random seed, the logger. So again, the logger is an itwinai logger, which could be a single logger or a collection of loggers. Again, this will be covered in a separate video, so stay tuned for that. Metrics. So again, the users can pass a dictionary of metrics to be used during training and to be reused during validation, training, and test. And again, also checkpoints and how often to save checkpoints. I think that the most important argument is the config. So the config is a wrapper of a user-defined configuration, user-defined training configuration, which which gives the user a lot of flexibility on the configuration parameters to be used during training, and thus it's easily extensible. And usually this configuration can be employed to store hyperparameters such as learning rate, batch size, name of the optimizer, momentum. Okay, so the configuration by default will be implemented using the training configuration. So if you go to the config, so then we look for itwinai.torch.config.training configuration. So this provides a template for the training configuration, which again can be overridden by the users and extended by passing let's say giving configuration items inside the config argument that we were seeing before. So again, if we go back to the trainer, the user can set values in this dictionary, and then these values will override the standard training configuration, which is a data class and already provides support for different values, such as batch size, whether to shuffle, train, validation, and test datasets, clean GPU memory, number of workers to be used in the data loader when loading batches, learning rate, optimizer momentum, and so on and so forth. So under the hood, when you give some values, when you specify some values in this config, these values will override the training the values in the training configuration. So okay, so we made it till the end of this first tutorial on the TorchTrainer. So, well, stay tuned for more videos, and thanks for attending this tutorial. Cheers!